All right, hey there. I'm just going to go over a few problems. I've already solved them out. I've color coordinated some things. So, number 4, how many years will it take for an initial investment of $25,000 to grow to $80,000 if the interest rate is 6% compounded monthly? So, the first thing I did is I went through the problem and I kind of labeled things. So, in blue, I'm going to be using this laser pointer. In blue, we have years, so that's going to be our time. Initial investment of $25,000 is our principal. To grow to $80,000, that's the amount that we're working with at an interest rate of 6%. So when we're working with interest rates, we need to convert it to a decimal, so that's 0.06 is our rate. And if it's compounded monthly, that's going to be 12 times per year that it's compounding. So for this, we are using our formula here for interest that's compounding like on certain intervals. And so we're just going to plug in the information. So if you see A should be green, so that's my 80,000, equals my principal, which was 25,000, times 1 plus my rate, which is a decimal, 0.06, divided by how many times it's compounded, that's n, which in this case is 12. And then that's raised to the power of, again, our n times our time. And those are our exponents. So we just kind of work it down by solving. So we divide 25,000 to both sides first. That left me with 3.2. I think in the other answer key, it may have just been left as that amount. And then we have once we get that, in order to solve for an exponent, if we have an unknown or a variable in our exponent, we are going to natural log both sides, or we can log both sides. I used a natural log. So when I natural log here, I was left with natural log times 3.2. And when I natural log this side, I do that because I'm allowed to take my exponent and move it out front. So that's how I have this here. So I'm trying to get t by itself. So the whole thing is if I can move this out front, then what I'm able to do is divide everything else that was with it to both sides. When I divide that, then I'm able to calculate it in the calculator, because we are using calculators on this unit, and I get 19.43. So the question was how many years, and it would be about 19 years. It's really closer to 19 and a half years, but we're dealing with whole years, round to the nearest year. So our answer here is 19 years. Okay, so that's number 4. Number 5, Jerome is buying a new car for $15,000 in 5 years. How much money should he invest so that if he invested at 2.1% compounded continuously, so this is going to be our different formula for compounded continuously, will he have enough to buy the car? So, and we're rounding to the nearest dollar, the answer. So we're going to use a different formula. We have our amount equals the principal times E raised to the rate times time power. So as long as we can keep those formulas straight and pull the information out of our problem, then they do become pretty easy to solve. So I'm taking my amount, 15,000, that was in red, equals my principal. We don't know how much that is, so that's my blue highlighted up here. We don't know how much that is, so we're leaving that times E, that's just the number value, right, raised to the 0.021 power times 5. So it's 5 years times 0.021. In this one, I calculated, we were able to calculate 0.021 times 5, and that gets us 0.105. So I'm going to zoom in here. 0.105. So when I multiplied this, I got this. And then I'm dividing both sides by e to the 0.105 power. When we divide both sides, that cancels those out so that we're left with p by itself equals 15,000 divided by e to the 105 power. And when you put that in a calculator, you get a number similar to this. I think I rounded here, but we needed a whole dollar, so we're talking $13,505 is how much he would have to invest at 2.1% interest compounded continuously for it to grow into $15,000 in 5 years. All right, last two. Number 8. So number 8, we're using another different formula here. And the formula that we're using, I hope that's not this one. The formula that we're using is right here. So our amount, our new amount, or whatever amount we're working with equals the original amount times e raised to the rate, we're using k for rate there, times time. So there's kind of two parts to this. The first thing is we have to find the rate of change using the info that was given to us. So there's enough info here to find the rate of change. The second thing we'll do once we've done that is we're going to use that rate of change to solve for the years, or whatever the second part of the question is that they're asking. So in 2000, the population of Santa Cruz was 150,000. That's our original amount. In 2005, there were 177,000 people. So I wrote 177,000 equals 15,000. So my new amount equals my original amount times e raised to the k times 5 power. So I divided these out. I'm trying to get e by itself so that I can natural log it. So I divide that to both sides. That gave me 1.18. I think in the other answer key or in the other problems worked out, they left it as like 177 over 150. And you would leave it like that so that you're, like if I had to round a decimal or something, we would want to leave it like this because it's going to give us the most accurate answer. As we round and then use those numbers when we round, it throws our answers off by increments. Let's see. So I natural logged both sides. That canceled out my e and left me with natural log of 1.18 equals k times 5. And then I was able to divide 5 to both sides to get k by itself. And then when I calculated this in my calculator, it gave me 0.0331. So that's my rate of change. That's my k. I can then use that in part 2 in the same formula, but now I'm using a little bit different info. So I want to know if it's growing exponentially, so that was this formula, how many years, so now I'm solving for time, so how many years will there be 210,000 people? So when I set this up, time is my variable that I'm solving for. This is my k. We figured that out from from part 1 of this problem. And then we have 210,000, I just dropped the thousands here, equals 150 times e to the raised to the 0.331 times t power. So the first thing I did, I divide 150 to both sides so I can get e by itself. Once e is by itself, then I can natural log both sides to get rid of e. I'm left with the natural log of 1.4 equals 0.331 times t, and to get t by itself, I'm dividing 0.0331 to both sides. And then when we calculate that, we get 10.17, or approximately, it was asking in whole years, approximately 10 years. So it would be about 10 years for the population to grow at that rate. Okay, and then number 9 is very similar. So we have two parts to this problem. The first is where we're finding our rate using the given information. We're doing that on this side. And then we're going to use that rate to figure out time. So on this side, I have 350, which is my current amount, equals 1200, which is my original amount, times E, raised to the K, that's our rate, we don't know that, times 15. That's how many years. So from 1995 to 2010 is 15 years, so we're using 15 there. I divide 1200 from both sides, and this one I left, instead of putting the decimal, I left it as a fraction. It works, like I said, the same. It'll be more accurate that way. If there's like a huge decimal that we'd have to round, this gives us a more accurate answer. So I natural log both sides. So that's natural log times 350 divided by 1200 equals K times 15. Then I'm able to divide 15 to both sides. And when I calculate this, make sure you use parentheses in your calculator, those kind of things. I did it on my phone just fine. So I know we don't like the phone calculators for doing this kind of level of stuff, but if you are careful with it, you can get to the right answer. It gave me negative 0.0821. So that's my rate of change. So now I'm going to use that in the second part of the problem when we're trying to figure out in what year will there only be 100 whales. So we know that our amount of whales would be 100, and we're solving for time. We're using the rate that we found before, and so we're saying, and our original amount. So 100 whales equals the original amount, which was 1200, times E to the T times K. Now T we don't know. We don't know how many years, but we did figure out our K. So we divide 1200 to both sides. I rewrote it as 1 over 12, just got rid of the zeros. I just reduced the fraction, but I didn't actually evaluate the fraction. Then we natural log both sides. And that gives us the natural log of 1 over 12 equals T times negative 0.0821. So to get T by itself, I'm dividing this to both sides. And when I divide that to both sides, I get 30.26. I rounded a little bit, but it's really asking years, so 30 years. And it wants to know in what year will there only be 100 whales. So I took 1995 plus 30 years, and that brings us to 2025. Okay? Hope you're well, and I hope this helped.